Hello friends, welcome to my YouTube channel Physics Programmers. Today I will teach you how to do numerical integration and I will show you the trapezoidal rule as a special case of Newton-Cotes formalism. I am Shubhadeep from IIT Kanpur. Let's begin. So we have to do numerical integration for a given function fx over the given interval a to b numerically. So for different fx, it is sometimes cumbersome to calculate the integration value for any given fx. Okay, so for that we have to use our computer, which will do the same for us, and it will be very easier to do it in computer. So we have to find fx integration over a to b fx dx. So first, Newton-Cotes formula. The integration can be evaluated using weighted sum of the integrand function fx, and the points will be, the weighted sum will be evaluated at some points, and that points will be equally spaced. So that equally spaced points are given by this xi, which is given by a plus ib minus a divided by n minus 1. So as n points are there, so n minus 1 number of segments are there. Okay, so for that, if I equals to 0, then xi will be x0 is basically a, and for I is equals to n minus 1, then it will be just b, x n minus 1 is equals to b. So we have to calculate the integration, and it will be approximated as the sum. This is a weighted sum at this xi points, and for xi point the weights are wi, which we have to calculate. This we have to find these weights wi's. Now for n points rule, we have n number of unknown weights wi's. So n means w0 to wn minus 1, we have to find it out, and we can formulate n linear equations to solve for all the wi's, and we can formulate an exact equation that give the exact results for the polynomials up to order 0 to n minus 1. So 0 means the constant function, and n minus 1 polynomial means we can have the function have some x to the power n minus 1. So we have to calculate this with, we can do the exact results. Okay, so first important message here is that if we use n-point Newton-Cotes rule, you can integrate exactly up to the polynomial of order n minus 1, because we can just formulate n number of equations. Now trapezoidal rule. So points are like a is equals to ib minus a divided by n minus 1. So trapezoidal rule is 2-point Newton-Cotes rule. So for that we can have only x0 and x1, and x0 will be a and x1 will be b. So for that we can approximate this integration as w0 multiplied by fx0 plus w1 multiplied by fx1. So we have to find these two unknowns, that w0 and w1. So for that we can just have, as we are using 2 points Newton-Cotes formula, so we can integrate exactly for linear functions only. Okay, so for 0th order polynomial, so that means fx is equals to 1. So then, because if this is exact, then fx is equals to some constant, it will be exact because it will be just a multiplicative factor. Okay, so for that, then w0, if x0 is 1, so this is w0 plus w1, and the exact result is equals to b minus a. Okay, and for order 1 fx is equals to x, then this w0 will be multiplied by fa, and fa is a, and here w1 multiplied by fb, where fb is b. So if I just integrate x from a to b, then I will get b square minus a square divided by 2. So this is the exact result. So these two equations we can formulate to get the exact results, and after that we will have some errors. Okay, but from these two equations we can just easily calculate this w0 and w1, which are linear equations here. So these are two linear equations, W0 and W1. So after solving these two equations, we can get W0 and W1 is equals to b minus a divided by 2, and our formula becomes fx dx integration over a to b is b minus a by 2 multiplied by fx0 plus fx1, which can be easily written as b minus a, and fx0, x0 is a, so that is why this is fa, and fx1 is basically fb. So this is the trapezoidal rule. This is very simple rule, and it is very common formula for us. Now what is the geometric interpretation? So geometric interpretation, here you can see that if this cyan colored line is the function fx as a function of x, and here you can see just this is the b point, x equals to b point, this is the x equals to a point. So then you can see that we need to calculate the area under this cyan curve, okay, but we are approximating with some this b minus a, and the area is actually, you can see that b minus a multiplied by this height, and this height is actually fb plus fa divided by 2, and which is the average of these 2 points. Okay, so this is the final fb and y is equals to fb, and this is the y is equals to fa, and you can see that this is the area, this green area is the approximated integration. So and you can just interpret it as like that this red dashed trapezium, so this is the exactly same area with this trapezium of this trapezium. So this red dashed curve, which is actually implying some trapezium, and its area should be equals to this green area, and this is the approximated value using trapezoidal rule. So from this trapezium, actually this trapezoidal, this word has come. Okay, if you use more trapezoids, you will get more accuracy. Why? Because you can see that if you just have only one box like this, one rectangle, then the variation of this fx is larger, and you cannot ignore this variation. But as this number of intervals are more, then you can see that within this interval this is more like linear, this function is more like linear. And as you know that trapezoidal rule can calculate exact integration with linear functions, so therefore with more number of intervals you can calculate more accurately these integrations. Okay, so as we know that integration over a to b fx dx is equals to a to c and c to b. So this integration is first integration is from a to c, and second integration is from c to b. So if we add them, then we will get the result. So we can just create smaller intervals to integrate and sum them up, and we can just write like this. So our intervals can be like b minus a divided by n. So we can just divide into n intervals, and our integration become this a to b integration over fx dx is equals to, the first integration will be a to a plus h, the second integration will be a plus h to a plus 2h, and dot dot dot. So this will be ultimately a plus n minus 1h, and this b is actually a plus nh. So this is how we can just create such different intervals. Okay, and we can integrate in different intervals, successive intervals, and we can just add them up to get the desired integration. So if we just we can see that if I just increase the number of intervals in, and we can just check the relative error. So this is actually done for the exponential of minus x. Okay, So for fixed a and b, we have done this integration and we have just plotted it. This is in log scale, and so that is why this power law actually looking like a straight line, and this line is actually proportional to the n to the power minus 2. So as n will increase, the relative error will be lesser. So because we know that the exact result for the integration, and we have just compared with the exact result, and the relative error is actually decreasing with increase in n. So if we increase the n tends to infinity, then it will be exact. Okay, the integration value will be exact. So for homework, you can do the same analysis for 3 points rule. We'll take just 3 points instead of 2 points. So then the calculation will be a little more cumbersome, but it is doable in by hand. You can just do it analytically, and you can end up with Simpson 1/3 rule. Okay, and the 1/3 rule, actually using 3 points, actually that can integrate up to quadratic functions accurately. Okay, so in conclusion, we understand the formula for the numerical integration using Newton-Cotes. With n point rule, one can integrate up to n minus 1 order exactly, polynomial of n minus 1 order exactly, and more number of intervals means more accuracy, and relative error goes as n to the power minus 2. Thank you. Subscribe my channel.